Space and time seem like two really separate ideas. I mean, I can walk 2 meters to the side. But traveling an hour into the future sounds straight out of science fiction. Or is it? Now time travel starts to make a bit more sense with Einstein's amazing general theory of relativity. What's it all about? General relativity expands on Newton's law of universal gravitation and Einstein's earlier theory of special relativity. The theory rests on the assumptions that the speed of light in a vacuum is constant and that the laws of physics are the same in all reference frames. This means that if you had an observer in a rocket in deep space accelerating upwards at 9.8 meters per second squared, then that observer wouldn't be able to tell that he or she wasn't just on a room on Earth and vice versa. Einstein's idea changed the notion of gravity from a force to a geometric property of space-time. But what does this mean about our universe? Let's find out. First of all, we're going to have to think of space-time as less of a shapeless void and more of something like a fabric. Now, just like any other fabric, space-time can curve. But what causes it to curve? In general relativity, space-time curvature is directly related to a quantity known as a stress-energy tensor. This describes the amount of energy and momentum in a particular region of space-time. And since we know how mass is related to energy, it makes sense why something with a lot of mass can curve space-time a lot. So if I get these two balls here and drop them onto the cloth dictates their motion to move inwards towards the more massive object, almost as if there was a pulling force, a form of gravity. Actually, what we perceive as gravity is just the warping of space-time around more massive objects. This has an interesting consequence. Imagine two observers, one in deep space and one near a massive planet. Both observers have a specialized clock known as a light clock. Here, a photon travels and bounces between mirrors to measure 1 unit of time. Now the observer near the planet experiences a greater warping of space-time. This means that the photon in his light clock would have to travel through more space-time to complete one cycle. But since the speed of light is constant, his clock would consequently tick slower. If he compares his clock to his friend's in deep space, it would appear as though his friend had traveled into the future. Doesn't seem so science fiction-y now, does it? Well, we just proved that gravity is a consequence of space-time geometry and that time travel is possible. And I guess this tells us that science fiction doesn't always have to stay fiction. With enough perseverance and scientific progress, we can make it a reality.